Welcome back, mathematicians. In this video, we are going to solve more trigonometric equations. We're told that to solve this equation, we're going to look for angles theta that are greater than or equal to 0 but less than 2 pi. Now, if there is a solution for angle theta, it is known that there will be infinite solutions because of the cyclical nature of our trig functions. But we're being told to just look for theta from 0 to 2 pi, including 0. Now, for this trig equation, what makes this challenging is that you're evaluating the tangent function for the expression theta minus pi over 3. Now that pi over 3 actually, if you think of the graph of tangent, represents a horizontal shift to the right by pi over 3 units. To make this a little easier, what we're going to do is let u equal the expression theta minus pi over 3. What we can then do is convert this equation into tangent of u is equal to square root of 3. This then converts it to an easier equation for us to solve, which we'll then use to find the values for theta. Now keep in mind that square root of 3 is really square root of 3 over 1. And so if you are using your unit circle, you're going to find angles that when you are looking at the unit circle, the ratio of y over x is positive square root of 3 over 1. Now, if you're drawing yourself a couple quick pictures, what you'll note is that tangent is equal to a positive ratio in quadrant number 1. And so that would be the opposite side of square root of 3, adjacent side of 1, hypotenuse or radius of 2. And so this angle this angle u is one of our solutions. And so u is equal to pi over 3. The other picture would be in quadrant number 3, and it would be this picture here, where the adjacent side is negative 1. The opposite side is negative square root of 3, and the hypotenuse is positive 2. And so this is our second solution. Because that reference angle is pi over 3, we're going to take pi plus pi over 3 to get 4 pi over 3. So those are our two solutions for u. But our goal here is to find solutions for angle theta. To do this, we're going to go ahead and write two general formulas, which would allow us to find as many solutions as we want, but we will focus on solutions that are from 0 to 2 pi, including 0. So to find our general formulas, we're going to take theta minus pi over 3, set it equal to the value of u, which is pi over 3, plus pi times k. The reason for pi times k is that pi represents the fundamental period of tangent, and then k is an integer multiple of pi, meaning that every pi units we're going to continue to repeat values in our trig function. The second formula is going to be theta minus pi over 3 is equal to 4 pi over 3 plus pi times k. So those are our two general formulas. Now to simplify this, we're going to go ahead and solve these general formulas for theta by adding pi over 3 to both sides. And we're doing this to both formulas. And so what we get for our final version of these two general formulas is theta is equal to 2 pi over 3 plus pi times k, or theta is equal to 4 pi over 3 plus pi over 3, which is equal to 5 pi over 3 plus pi times k. Now, as I mentioned, k represents an integer multiple. So k is an integer. So what we will do to find specific values for theta is to replace k with integers and then solve. So first, let's start with 0. So k is equal to 0, which means theta, when you replace k with 0 and simplify, will be 2 pi over 3 and 5 pi over 3. Now we keep going and we go to k is equal to 1. And so when k is equal to 1, we're going to take 2 pi over 3 plus pi, which is 5 pi over 3. And for the second one, it's going to be 5 pi over 3 plus pi, which is going to be 8 pi over 3. Now you do see that one of the values is repeated. We don't write that twice. That does happen periodically, especially with tangent. So we are going to stop here, however, because we see that 8 pi over 3 is actually larger than 2 pi. So we don't want to keep going, although we could if we'd like to. So one of the things you may be asked is to find 6, 7, 8 solutions, because these two formulas will find infinite solutions, as many as you want. But we're stopping here because 8 pi over 3 exceeds 2 pi. Now the two solutions we're going to focus on, however, are 2 pi over 3 and 5 pi over 3. So even though we have 5 pi over 3 represented twice in our work, we're only going to write it once for our solution. Sorry about that terrible looking 5. There we go. And that's how you solve this equation. Let's now go to our second equation, where we are being asked to find angles of theta that are greater than or equal to 0 but less than 2 pi. Now in this case we have sine of the expression 2 theta. Now that 2 represents a horizontal compression of the graph of the sine function. As a result, this will mean that we have more solutions than if there were not that 2 as a coefficient of the angle theta. So what we're going to do, similar to the last problem, is let u equal 2 theta. We're going to convert this to a simpler problem for us to solve. So it's going to be sine of angle u is equal to square root of 3 over 2. Now we solve this using our pictures or our unit circle. If you're using your unit circle, you're going to find angles that have a y-coordinate on the unit circle of square root of 3 over 2. Or you can draw yourself two quick pictures. We know sine is equal to a positive ratio in quadrant number 1. So we'll have our terminal side in quadrant number 1. We have the opposite side as square root of 3, hypotenuse or radius is 2. That means the adjacent side is 1. So this is one of our solutions for u. So in this case, u is equal to pi over 3. Our second solution for u will come from the second quadrant, where sine is also positive, a positive ratio. It also has an opposite side of square root of 3, also has a radius or hypotenuse of 2, but the adjacent side is negative 1. This is our second solution for angle u, and so that would be an angle of 2 pi over 3. We are now going to be tasked with finding two general formulas. So the general formulas are going to look like this. What we have is 2 theta is equal to the first solution for u, which is pi over 3, plus 2 pi times k. Now the reason it's 2 pi times k this time is because 2 pi represents the fundamental period of sine, whereas the last example we just used pi because that was the fundamental period of tangent. Or we have 2 theta is equal to the second solution for u, which is 2 pi over 3 plus 2 pi times k. Again, k represents integer solutions or integer multiples of 2 pi because, again, every 2 pi units, the sine function repeats itself. Now what we're going to do is solve for angle theta. To do this, we're going to divide all terms by 2. And so now we get two general formulas rather, which is going to be pi over 6 plus pi times k, or theta is equal to pi over 3 plus pi times k. So now our task is to replace k with integers to find solutions for theta. So we'll start with k is equal to 0. And when k is equal to 0, replacing k with the value 0 and simplifying both expressions, we see that theta is equal to pi over 6 and pi over 3. Now we do the same thing for k is equal to 1. And so for when k is equal to 1, we're going to take pi over 6 plus pi. So that means theta is equal to 7 pi over 6. We are also going to take pi over 3 plus pi, which means theta is equal to 4 pi over 3. We now think about k is equal to 2, but we're going to stop right there. Even though we could keep going as many times as we want to find as many solutions as we want, we are going to stop right here because, again, we are told that theta is less than 2 pi. Well, if k is equal to 2, then what you're doing is taking 2 pi plus pi over 6. That is going to exceed 2 pi. You're taking 2 pi plus pi over 3. That will also exceed 2 pi. So this is going to, k is equal to 2 will exceed 2 pi, so I'm not going to include this. That means our four solutions are pi over 6, pi over 3, 7 pi over 6, and 4 pi over 3. All right, guys, good luck.